Good evening, everybody. My name is Daniel Levesque, and today I will be utilizing the CRA approach for Standard 3.4 in mathematics. The standard I have chosen states that students will create and solve single-step practical problems that involve multiplication and division through 10 times 10. The reason I have chosen this standard is there are a variety of different options for the different stages. So although I am showcasing what I would utilize in my classroom, there are still a ton of other options for teaching this specific standard. For the first standard, the concrete stage, which utilizes tangible objects, stuff that the students will be doing hands-on activity with, I have done grouping. And in my example, I'm utilizing rocks, but you could also utilize Play-Doh, gummy bears, Skittles, any kind of tangible objects that the kids can put their hands on and move around as they need to. But when it comes to grouping, this can be done for both multiplication and division in that you can have the students take the rocks that they have, whatever the amount may be. In this case, it is 12. And you can have the students break them up into these different groups so that way they're able to group them. So I've done it. I've taken the 12 and I've grouped them in 3 groups of 4. So I've got this group, and this group. So in my problem, I would have 3 groups, 4 rocks. So if I have 3 groups, each having 4 rocks, it's going to equal 12. And again, you could do this with multiplying, or you could do this with dividing. So if you know that you have 12 rocks in all, and you already have them in 3, say you figure out that you need to put them in 3 groups, you can say that 12 divided by the 3 groups is going to equal 4. Or you have the 4 rocks and you figure out that you need to put them in 3 groups, and then you can get the 12 divided by 4 equals 3. That is the concrete stage. The next stage that I have with the next strategy that I'll be using is 10 frames. For 10 frames, usually it would work best with multiplication, but you could also do this with multiplication and division. For this one, the students will be creating their own 10 frames for the representation group, which utilizes things that the students will be drawing rather than having tangible objects that they will be moving around. But in this example, like I said, for the 10 frames, the students will create their own 10 frames like I have here, and they'll fill them in for however the problem calls for, what the numbers they'll be using. In this case, again, I'm doing 3 groups, each having 4 circles in all. So then if you have 3 tens frames, all with 4 circles in each, you could say 3 times 4 equals 12. So that is the strategy that I would be utilizing for the standard, for the representation stage. The next one that I have for the abstract stage is word problems. So because for the abstract stage, the students need to utilize more mathematical symbols and start to be able to do it mentally, or utilizing the proper form of the problems by this stage. What I've done is I've chosen to do word problems so that they can still kind of visualize how the problem should be set up, but when they write it out, when they're solving the problem, it's going to look like how it would like on a test or a worksheet or anything like that. So for my word problem, they could do whichever word problem that they set their minds to. But in this example, I have Johnny has 3 packs of baseball cards. Each pack has 4 cards in it. How many cards does Johnny have in all? So 3 packs, right? 3 packs, each having 4 cards. So when they set up the problem, 3 times 4 equals 12. They won't really need to draw out the 3 packs and that each pack has 4 cards, because with what they've done with the representation stage and the concrete stage, they've already, having done that so many times, they'll be able to visualize instead of actually needing to draw it out or move any material objects. So they'll just be able to write out the problem with the correct symbols, setting it up correctly, and be able to solve the problem. So that is what I've done for the CRA approach for standard 3.4 in mathematics.